Okay, they tell us that we have a cubic equation with the given roots. X is equal to 2, and they tell us x is equal to 4 plus I. And they want us to find, okay, polynomial p of x. Okay, that's what we're finding. Well, every time you have an imaginary value like this, there's another one that goes with it. So if they give you 4 plus I, then you're going to have x is equal to 4 minus I. They won't give that to you, but they'll give you one of the two. So if they give you the 4 minus I, then you know there is a 4 plus I. Okay, so what we really have here is, when you take this to the left hand side and write this in a factor form, that's x minus 2 is equal to 0. That's what we got from that. And when you take everything here to the left hand side, that will become an x, okay, x minus 4 minus I is equal to 0. That's another one of my factors. And then when I take everything here to the left, okay, that will become x minus 4 plus I is equal to 0. That was the other factor. So I'm going backwards now. So I want to find an equation p of x. So my p of x is going to be then x minus 2 times x minus 4 minus I times x minus 4 plus I. Okay, all we have to do now is multiply everything out and we have the answer. But you want to multiply the complex numbers first, because that will get rid of the i's for you. So we're going to take x and we're going to multiply everything in the third parentheses by it. So that means I'm going to leave my x minus 2 alone for right now. So x times all of this is going to give me, okay, x to the second minus 4x plus ix. Alright, now I'm going to take a negative 4 and multiply everything here in the second parentheses, or technically third parentheses. So negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. And negative 4 times I is going to give me negative 4i. Right, I have negative I have to multiply that through. Negative I times x is going to give me negative ix, or xi. Okay, and then negative I times negative 4 is going to give me positive 4i. And then negative I times positive I is going to give me negative I squared. Now in the brackets I'm going to clean that up because I can, otherwise it's going to be a mess. First of all, let's cancel out what we can. If you notice, I have a negative xi and a positive xi. They're going to cancel each other out. If you notice that I have a negative 4i and a positive 4i, they're going to cancel out. Alright, but we also notice that I squared is really negative 1. So this right here is a negative of a negative 1. So that will become a positive 1. Well, the positive 1 here will combine with 16, and that will give me 17. Okay, let's keep that in mind. So, if I clean this up, I have an x to the second. Negative 4x is negative 8x. Okay, and then 16. So this is gone, that's gone, that's gone. So the only thing left is 16, and 16 plus 1 is 17. So that's what I have. And I multiply the two complex roots. Now, the only thing that's left is to multiply the first parentheses into the second bracket. So x times all of this is going to give me x to the third minus 8x to the second plus 17x. And then negative 2 times all of that is going to give me negative 2x to the second, positive 16x, and then minus 34. Okay, so I got one last step to go. I have x to the third. That x squared and that x squared come together, I get negative 10x squares. And then 17x plus 16x, they come together. I'm going to get plus 33x. And then I have a minus 34. And that's my final answer. Okay. Let's go to another problem. Solving radicals. Here we go. This is 70. Okay, I have a rad 2x plus 1 is equal to rad x minus 3 plus 2. Okay, now, when you're solving radicals, you need to get rid of this radical by squaring it. But if you square that side, you'll have to square the whole thing here. This is easy. That's going to give me 2x plus 1. This is not easy, because that really means, if you really look at that, what you really have is a rad x minus 3 plus 2 times rad x minus 3 plus 2. That is what you have. So you have to use distributive property to multiply this out. So when I multiply rad x minus 3 times rad x minus 3, I'm just going to get x minus 3. The radicals will cancel. And the rad x minus 3 times 2 is going to give me plus 2 rad x minus 3. And then I have a 2 times rad x minus 3. It's going to give me plus 2 rad x minus 3. And then 2 times 2, which is going to give me 4. Okay, let's clean this up a little bit. Okay, I have a 2x plus 1 is equal to, this is an x. Okay, I have that, and negative 3 and positive 4 is going to give me positive 1. And this is 2 plus 2 of rad x minus 3, which will give me a total of 4 rad x minus 3s. Right, so I have to isolate this radical here, so I'm going to start taking everything to the left side. So when I take the x over, I just get an x because it turns minus. When I take the 1 over, that goes away, and I have a 4 times rad x minus 3. I'm going to divide both sides by 4, so I have x over 4 is equal to rad x minus 3. Now I've isolated my radical, so that means I'm going to square again. Okay, when I square again, I'm going to get x squared on the top and a 16 on the bottom, and I have a x minus 3. Then I have to take everything to one side because this is a quadratic. Well, you know what? Let's get rid of the fractions. So let's multiply both sides by 16. That'll make our life a little bit easy. Okay, let's multiply both sides by 16. I'm going to get x squared, and then on the right side I'm going to get a 16x, and 16 times 3 is going to give me a negative 48. It's a quadratic, so whenever I have a quadratic, I'm going to have to take everything to the one side and factor. So I got x squared minus 16x plus 48 is equal to 0. Now we have to factor, and we are going to factor right now. Okay, factors of x squared, that's easy, x and an x. I'm looking for factors of 48 that I can make a negative 16 out of. And it looks like 12 and 4 will work, so I'm going to go negative 12 and negative 4. Then I'm going to set that equal to 0. I get x is equal to 12. That's one of my solutions. Set that equal to 0. I get x is equal to 4. Now, I'm not quite sure that when I went around squaring everything and whatnot, that if any of this stuff really works out or not. So whenever you have radicals, so logarithms, okay, or fractions, you have to go back and check, see if these numbers work. Sometimes none of them work, sometimes both of them work, sometimes only one or two will not work. So let's find out. Let's go back to the original equation, which is why I'm erasing all of this. I'm going to plug in each one of these numbers. Okay, so let's plug in 12. Okay, when I plug in 12 right there, 12 times 2 is 24. 24 plus 1 is 25, and square root of that is 5, and that works. So let's put in 12 there. 12 minus 3 is 9. Okay, square root of 9 is 3. 3 plus 2 is 5. So I get 5 on that side. So we keep the 12. 12 works. Now we're going to have to try the 4. Okay, so you can't assume automatically that 4 works also. Okay, so let's put it in. So I'm going to put in 4. 4 times 2 is 8. 8 plus 1 is 9. And square root of that is 3. So I'm putting 4 in. Okay, when I put 4 in, 4 minus 3 is 1, square root of 1 is 1, 1 plus 2 is 3, so both of them work, we keep both of them. Okay, so that brings us to next problem. We've seen this problem before. This is number 72. Okay, you have y is equal to absolute value of x over x. Alright, remember last time we did this problem? We said, hey, this problem is really two problems in one because absolute value, the inside there can be positive, inside there can be negative. Well, what does that mean? So you can have, this is really a piecewise function. Y is equal to x over x when it's positive, okay, and y is equal to negative x over x when it's negative. Of course, this reduces to 1, and of course this reduces to negative 1. So you really have two problems in one. Well, where do things change is when x is equal to 0, because that's when it's undefined. So if we were to sketch the graph of this, it will look like this. Okay, it's a piecewise function. Okay, you have 1. To the right of 0, when x is positive, it turns into positive 1. So you got an open circle here, and then it goes to the right. And then at negative 1, okay, when x is negative, it turns into, y turns into negative 1, so you have an open circle here, it goes like that. Now, they ask us a question about the symmetry of these things. Is it symmetrical to the origin? When it is a symmetrical origin means when you put in some x and then you put in a negative of that x, do you get exact opposite values? We do. We get 1 and we get negative 1. So A is right. Okay? So A is right. So far we have A. Now we got to check for all of them. Is it symmetrical to the x-axis? That means when I fold on the x-axis, there's my x-axis, there's my y-axis. When I fold right there, will this, all these points, will they fall on top of these? No, they'll fall right here, underneath that, so to the right of it. So B is no. Okay, C, is it symmetric to the y-axis? When I fold on the y-axis, will this fall on top of that? No, it'll fall over here to the left. So the C is no. Okay, and is it symmetric to the line y is equal to x? Okay, and that is if you were to draw a dotted line, okay, through the origin, okay, let's say unfold on it, that's your y is equal to x. Okay, will this line here fall on top of this line here? No, it won't fall on top of this line. So D is no, so the A is my correct answer. Alright, I am going to do one more problem, and that's it. We'll do the rest of them in class. So 79. Okay, you're asked to simplify this. So you have a 9 minus x to the negative 2, all that over 3 plus x to the negative 1. Now there's a clever way of doing this, and there is a long way of doing this. Okay, so I'm going to show you a clever way. Okay, this will make your life really easy. This is really 9 minus 1 over x squared. And this is really 3 plus 1 over x. Alright, if you really look really close, the top one is really difference of two squares. It can be factored. Okay, you're going to get a plus in one and minus in the other one. So plus in one and minus in the other one. Okay, and the square root of 9 is 3. Okay, 3 is the first term. Square root of this is really 1 over x. Okay, 1 over x. Okay, now the bottom is really 3 plus 1 over x. So now this will cancel out with that, and my final answer is 3 minus 1 over x. You can leave it like that, or you can use that ancient Indian secret and multiply here, multiply there, multiply there. Okay, and then you can get the answer, which is 3x minus 1 all that over x. Either one is fine. You can leave it like that, or you can leave it as 3 minus 1 over x. Okay, both are fine. Okay, alright, so we're going to work in class from problem 67 through 86 on Monday. Okay, alright, that's it.